Hello everyone. So in this video we will discuss that why fluid cycle detection algorithm works. So friends, in our previous video we saw that how we can detect a loop in a singly linked list, and we also saw that how we can find the starting node of that loop. So the algorithm which we saw, it was just a code which usually works, but there was no proof that why this algorithm works. So in this video we will see that why a fluid cycle detection algorithm works. So friend, let's suppose we are given with this singly linked list. So here you can see that singly linked list contains 9 nodes. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you see that from the 6th node the loop starts and the last node points to the 6th node. So therefore this loop starts from here. So basically, in order to detect that whether this singly linked list contains a loop, what we do is we simply create two pointers. One is the slow pointer, another is the fast pointer, and we usually start it from the head. Now what we do, as the name suggests, the fast pointer moves 2 steps and slow pointer moves 1 step. And we perform these steps in iteration, that fast pointer moves 2 steps, then slow pointer move 1 step. So friend, if this singly linked list doesn't contain loop, then fast pointer will reach to the end of the singly linked list, where last node next will point to null. And if there is a loop, then fast pointer will keep on traversing here, and slowly slow pointer will enter the loop, and fast pointer will meet the slow pointer somewhere in the loop. So first let's see how it works. We moved fast pointer by 2 steps, slow pointer by 1 step. We moved fast pointer by 2 steps, slow pointer by 1 step. Fast pointer by 2 steps, slow pointer by 1 step. Now here, from here fast pointer reached here because this is the first step, this is the second step. Slow pointer by 1 step, fast pointer by 2 steps. So friends, here you can see that slow pointer is still completing this tail of the singly linked list, but the fast pointer has already completed one circle, and based on number of nodes and the size of the loop, there can be possibility that when slow pointer will enter the loop, fast pointer must have completed X number of cycles. So here you can see, now we'll move slow pointer, then we move fast pointer by 2 steps, so it will reach here, slow pointer here. Now as we started our algorithm with fast pointer, so we are moving fast pointer by 2 steps, and then our iteration will end with slow pointer with 1 step, so slow pointer will reach here. Then we'll again do a while loop and fast pointer will reach here, and then our iteration will end when slow pointer will reach here. So friends, here you can see when our iteration will end with the slow pointer, we see that now slow pointer and fast pointer are meeting at this node. So friends, there could be a possibility that based on number of nodes and the size of loop, there could be a possibility that before meeting the slow pointer, fast pointer must have completed this cycles X number of times, and similarly slow pointer must have completed this cycle, let's say Y number of times, before meeting at this node. So the first part of the algorithm is detecting this loop. In case if fast pointer meets slow pointer, then we know that there is a loop. So this is the first part of fluid cycle detection algorithm. The other part is to find the starting node of this loop. So after finding the meeting point of fast pointer and slow pointer, what we do is we keep slow pointer here and we move a temporary pointer from the head. And now this time we move slow pointer 1 step and temp also by 1 step. So what this algorithm will tell us is, if we move both the pointers 1 step, when temp will reach to the start of the node, slow pointer also will reach to that particular node. And basically in code, when they meet to any node, that node will be our starting point of the loop. So let's see how. We move temp by 1 step, we move slow pointer by 1 step. We again move temp by 1 step, slow pointer by 1 step. We move temp by 1 step, slow pointer by 1 step. Then again we move temp by 1 step, and slope pointer by one step. So friends, here you can see that based on number of nodes here in the tail and in the loop, you saw that slope pointer started from here and it completed one cycle and reached to the same point here. And now if we move temp by one step, it will reach here, and if we move slope pointer by one step, it will reach here. So this algorithm tells that at whichever node these two pointers will meet, that would be our starting point of the loop or the starting node of the loop. So now there are two parts of the algorithm. One is of detecting the loop, that is the meeting point of the slope pointer and fast pointer, and other is the finding of this starting node. So here if we draw this singly linked list, let's say something like this, that this is the tail and this is the loop, and let's say they meet at this point. So here you can see we are denoting this tail with a value m, and fast pointer comes inside the loop, it goes and performs few cycles and reach here, and slope pointer also performs a lesser number of cycles and finally meet it here. Or it could be possible that slope pointer doesn't complete any cycle and simply meets here. So we are giving this distance as k, and the complete length of this loop, let's say we are denoting it by n. So this is the current picture from where we will start our proof. So let's say we are assuming that fast pointer and slope pointer meet here. If they meet here, then this singly linked list must be containing a loop. At the start we are simply assuming that let's say they meet here. So the distance traveled by fast pointer would be, let's say we denote it by df. So the fast pointer will start from here, it moves m distance, and there could be possibility that fast pointer travels this loop, let's say x number of times, and once it performs the loop, it will come to the starting point only, and then it goes k distance and meet the slope pointer. So we can simply write the distance traveled by fast pointer as m plus the n is the length of this loop, and cf is an integer which can be like 1, 2, 3, 4, 5. So we are not sure that how many cycles fast pointer will perform, so we are denoting it by a constant cf, which would be an integer. So it can make one cycle, it can make two cycles, it can make three cycles. So in order to calculate distance, we are multiplying n by cf plus k. So if the cycle starts from here, it will reach back here and then it goes k distance. So this is the k distance. And similarly, distance traveled by slope pointer, let's say we denote it ds, it would be m plus, let's say the slope pointer also performs some of the cycles around this loop, and we don't know how many cycles it performs, so we denote it by cs. So this is also a constant, basically an integer value multiplied by the length of the loop, plus, so if it starts looping from here, then it performs one loop, or let's say cs loops, and then it will travel k distance and meet the fast pointer here, so plus k. So now as we know that both the pointers are starting at same point and meeting at this point, so the time travel by both the pointers will be same, and as fast pointer is moving 2 steps and slope pointer is moving 1 step, so the distance traveled by fast pointer will be twice the distance traveled by slope pointer. So let's say distance traveled by slope pointer is x. So if the fast pointer is moving twice the speed of slope pointer, then the distance traveled by fast pointer will be 2x. So if we substitute these values in x and 2x, it would be something like this. X will be equal to m plus n cs plus k, and 2x will be m plus n cf plus k. So here the constants are different, cf and cs, which are nothing but the integer values. So m plus n into cf plus k. Now what we do is we simply subtract x from 2x. So we simply subtract this equation from this equation. So what we get is this x will get cancelled out with this x, so only one x will remain. So here you can see m will cancel out k will cancel out. And if we do n into Cf minus n into Cs, taking n common, it would look something like this, n into Cf minus Cs. So this would be the equation which will be coming out. So friends, here you can see that based on the what equation came out, if we closely observe this equation, then here you can see that this x is equal to n into Cf minus Cs. So here you can see n is constant because this length of the loop will remain the same, and Cf minus Cs are nothing but integers. So there will be a value for Cf and Cs when multiplied by n will give us a distance x. So here you can see that if we substitute some of the values in the left hand side and in the right hand side, let's say for Cf and Cs and x and n, so you will find that this equation is solvable. So which proves that this equation is derived when we assume that they will meet at this point. And if they are meeting at this point, then there will be a loop inside the singly linked list. So you can try to substitute many values here and you will see that you will find the solution of these equations. So this proves our first point, that how we detect that there is a loop in a singly linked list. Now we'll see that, let's say this is the meeting point, and if we move the slope pointer by one step and temporary pointer one step, then why they actually meet at the starting point of the loop. So this will be our second part of the algorithm which we need to prove. So here we go via same analogy. The distance traveled by fast pointer is df m plus ncf plus k, and distance traveled by slope pointer will be m plus ncs plus k. Now here what we do is, this is also we discussed that distance traveled by fast pointer will be twice the distance traveled by slope pointer. So which means df will be twice ds, because fast pointer is moving twice the speed of slope pointer. So the distance traveled by fast pointer will be twice the distance traveled by slope pointer. So if we substitute these values, we will get m plus ncf plus k equals 2 into m plus ncs plus k. Now we'll multiply 2 inside this and we get 2m plus 2ncs plus 2k. Now what we do is we'll take m this side, so if we take it this side, it will become minus m and minus k, and here we have 2m and 2k, so 1m and k will be subtracted, and here if we take 2ncs here, so it will be ncf minus 2ncs. So this equation after solving, it will look something like this, that ncf minus, because we are taking this side, so it will become minus 2ncs. This m we took it here, so it became 2m minus m, so it gave m, and k we took it here, so it became 2k minus k, which gave us a value k. So friends, here you can see that m is the length of the tail of the singly linked list, and k is the distance from the starting node to a point where the fast pointer and slope pointer meet, and n is the length of the loop. So friends, here you can see we'll take n common, so it would look something like this, and here you can see from the starting point till this point, this value is k, and total value of this loop is n. So if we denote this small semicircle as, or the arc as, let's say r, like this. So over this equation, what we do is we take k this side, so it becomes n into cf minus 2cs minus k. So friends, to k what we can write is, so here you can see that k plus r will be equal to n, because k is till this point and r is till this point, and if we add them we will get n. So what would be the value of k? It would be n minus r. So if we denote n minus r instead of k, it would look something like this. N minus r came here. Now we'll multiply minus into this bracket. So it would look something like this. Minus n plus r. And now if we take n common from these two terms, we will get something like this. Cf minus 2cs minus n. So we are taking n common, so it will become minus 1. bracket plus r equals m. So friends, here you can see that this n is the length of the loop, and Cf minus 2Cs minus 1, here Cf is an integer, Cs is also an integer, and minus 1 is a constant. So what this equation denotes? So here you can see m, which would be the distance by the temp, and it will reach the starting point. And here you can see that if we are starting slope pointer here, then this equation, if we travel this much part n into some integer value, so that would be the number of loops where n will be multiplied by, let's say, some integer value, or it can come out to be 0. So for timing, let's suppose this equation comes out to be 1. So it means if we are starting slope pointer here, it will perform one loop and will reach to the same point. And let's say if this equation comes out to be 0, so it will stay at this point only, because this complete part will be 0. And if we take this value that 2, 3, 4, and if we are starting it from here, so it will travel like this, but it will always reach to this point only, because it is starting from this point. So this part is telling us that if we are starting the slope pointer here, and whatever the value this equation comes in the bracket, it will always make it reach to this point only. And here you can see if we travel plus r after making few cycles by this equation, slope pointer will reach here only. And if it travels plus r, then it will meet the temporary, because here you can see m is equal to some loops plus r. If temp will move m steps, the slope pointer has moved some number of cycles, and it would have reached here, and then it would have moved plus r, so it would have meet temp here. So which means that based on our values here, from this point, if slope pointer travels, let's say 1 cycle, 2 cycles, 3 cycles, it will reach here only. And meanwhile m would have reached somewhere here, because they are moving at same speed, one step. And finally when it would have traveled r, it would have made it somewhere here, which would be the starting node of our loop. So this equation tells that m is equals to some loops by the slope pointer plus r. So if we are starting from this meeting point, the slope pointer, it would have performed some loops, and it would have reached here only. And then based on our this length, which is r, it would have traveled r, then it would have reached the starting point of the node, and it would have met temp. So this equation is telling that if we are dividing our loop in k and r terms, and the total length of this loop is n, so we need to simply prove that slope pointer, if it is starting from here, then whatever distance it travels, it should meet the temporary node when temp has performed m steps. So here you can see when temp has performed m steps, which is this part of the equation, that would be equal to n into an integer multiple. So it is starting from here, it makes few cycles, it reaches to the same point, and then it is traveling simply plus r. So if it is traveling plus r, it would reach to the starting point of the loop, and where it will simply meet m, because m is equal to this equation. So friend, this proves that from the meeting point of the slope pointer and fast pointer, if we travel slope pointer by 1 step and temp by 1 step, so wherever they will meet, that will be our starting point of the loop. So friend, this proves that why fluid cycle detection algorithm works. In case you find this information useful, then please like this video, and if you are new to my channel, then please subscribe to my channel so that you never miss any update. Thanks, have a nice day.